Good morning, everyone. Welcome to our final project presentation for 190-106 G3 Generative AI application. Today, we're excited to present our AI-powered chatbot. Before we dive in, I'd like to introduce the team behind this project, collectively known as Trojan members. We have Ong Kiao Fio, L. Peter San Ong, Kong Miat Tun, Pang U Thant, Thin Theory Zhao, Samia Ali, and Lin Akari. Each member played a crucial role in bringing this chatbot to life. Here's a quick look at what we'll cover today. We'll start with an introduction to our project, move on to the system flowchart to understand its internal workings, discuss the implementation details, highlight the issues the model solves, acknowledge the drawbacks of our model, explore our plans for future development, and finally, conclude with a summary of our findings. Let's begin with the introduction to our project. Our AI-powered chatbot is designed specifically as a customer assistant for a technology shop we've named Tech Store. Its primary function is to provide recommendations for phones and computers, but it also handles a range of other customer service requests. What makes our chatbot effective? Well, users can ask questions in normal conversational language, eliminating the need for specific keywords. The chatbot is designed to understand what the user wants, interpreting their requests and intents accurately. It supports a variety of phones and laptops from different brands, leveraging a static product catalog. And importantly, the chatbot gives instant replies, ensuring a quick and efficient user experience. Now, you might be wondering about the AI behind this chatbot. While our course focuses on generative AI, for the core intent recognition in this project, we primarily used a traditional machine learning approach. The specific AI model used is logistic regression. This model is crucial for classifying user messages into different predefined intents, such as sales inquiries, troubleshooting, or refund requests. It forms the backbone of our chatbot's ability to understand user needs effectively. Moving on to the system flowchart, this diagram illustrates the logical progression of user interaction within our chatbot. It all begins at the start point, where the system first loads model and data. That's our logistic regression model and the product catalog. The chatbot then enters a loop, waiting for user input. Once input is received, it first checks if the user wants to exit or quit. If yes, the chat ends. If not, it checks if the conversation is in active conversation mode. This is particularly important for multi-step dialogues like the refund process or product selection, where the chatbot needs to remember the context of previous interactions. If not in active conversation mode, the core AI part kicks in, predict intent. Here, we use a combination of TF-IDF, term frequency inverse document frequency, for feature extraction, converting text into numerical representations by weighting words based on their importance, and our logistic regression model to classify the user's input into one of several predefined intents. As you can see at the bottom, we support various intents represented by specific modules: gratitude, store location, refund return exchange, greeting, troubleshooting, fallback for unrecognized intents, laptop sales, and phone sales. Each of these intents triggers a specific rule-based response or dialogue flow within the chatbot. This structured approach ensures accurate and relevant responses. So, how can we implement this model in real life? Our chatbot is designed with practical application in mind. First, for deployment on online platforms. It can be seamlessly deployed on company websites, integrating directly into customer service portals. It's adaptable for e-commerce platforms, providing instant product information and support during the shopping experience. And it can even be integrated into messaging applications, making support accessible where customers already communicate. Next, let's look at the customer interaction flow. Users simply type their requests in natural language. The model then generates automatic responses. These responses are based on the predefined intents identified by our logistic regression model and the stored data, such as product specifications or store information. We achieve this through rule-based auto-generated responses. The chatbot uses predefined rules and templates to generate accurate and relevant replies for each identified intent. This ensures consistency and reliability in responses, which is crucial for customer satisfaction. Finally, we've considered escalation to human support, Recognizing that no AI is perfect, our system includes a mechanism to transfer complex queries or situations that require human empathy and nuance to a human customer service staff member. This ensures that customers always get the help they need, even when the chatbot reaches its limits. Our AI-powered chatbot specifically addresses several common challenges faced by customer service departments. Slow response time. With our chatbot, customers no longer need to wait long for replies to common questions. It provides immediate answers, significantly improving response times. High volume of repetitive questions. Customer service agents often spend a lot of time on repetitive inquiries. Our chatbot automates responses for questions about price, specifications, and availability, freeing up human staff. Limited customer service hours. The chatbot provides 24/7 support. This means the model provides assistance even when human staff are unavailable, extending service accessibility around the clock. Inconsistent information. Human agents might sometimes give slightly different answers. Our chatbot ensures all customers receive the same accurate and up-to-date responses, maintaining consistency across all interactions. Overloaded customer support staff. By handling basic inquiries automatically, the chatbot significantly reduces pressure on human staff, allowing them to focus on more complex or sensitive customer issues. Customer confusion during product selection. For a busy tech store, guiding customers to the right product can be challenging. Our chatbot guides customers to suitable laptops or smartphones based on their stated needs, making the product selection process much simpler and more intuitive. While our model solves many problems, it's also important to acknowledge its current limitations, which we've outlined as drawbacks. It works best with simple and clear messages. Because our intent classifier relies on a more traditional ML approach and a defined set of intents, very complex or ambiguous phrasing can sometimes lead to misinterpretations. It cannot fully understand complex sentences. Similarly, sentences with multiple clauses, nuances, or abstract concepts are challenging for its current design to fully grasp compared to a generative AI model. Accuracy depends on training data quality. Like any machine learning model, the performance and accuracy of our logistic regression classifier are directly tied to the quality and breadth of the training data it received. If the data is limited or biased, the model's accuracy will reflect that. Limited understanding of user context. While we have elements of active conversation mode, the chatbot's ability to maintain context over very long multi-turn dialogues or to infer unstated user goals is still limited. It primarily focuses on immediate intent classification. Looking ahead, we have a clear roadmap for enhancing our chatbot's capabilities and addressing its current limitations. Our plans for future development include adding more training data. This is fundamental. Expanding our training dataset will significantly improve the intent recognition model's accuracy and ability to handle a wider variety of user queries. Supporting more languages. To reach a broader user base, we plan to implement multi-language support, allowing customers to interact with the chatbot in their native tongue. Using advanced AI models for better understanding, we aim to integrate large language models, LLMs, into our system. This would allow the chatbot to move beyond strictly predefined responses, handle more diverse user phrasing, follow-up questions, and provide more natural and flexible conversational interactions. Integrating real-time product prices and availability from online stores. Currently, our product catalog is static. A crucial improvement would be connecting to live databases and external APIs to provide accurate, up-to-the-minute information on product pricing, stock levels, and order validation. Improving budget and specification filtering. We want to make the product recommendation process more sophisticated, allowing users to apply more granular filters for budget, specific hardware requirements, and other preferences. This would also involve integrating fuzzy string matching and entity extraction techniques to recognize partial product names or spelling variations, making the interaction more forgiving and user-friendly. We also plan to complete and refine the refund and return workflow with confirmation steps and tracking. In conclusion, Our AI-powered chatbot project demonstrates a successful implementation of a practical customer assistant using traditional machine learning techniques, specifically logistic regression, powered by TF-IDF features and a scikit-learn pipeline. It's designed to streamline customer support operations and provide instant, consistent information. We firmly believe that AI is a tool, not a threat. Its impact depends entirely on how we choose to use it. When applied responsibly and ethically, AI can be a powerful force for good. Great opportunities await us in the field of AI, particularly in enhancing customer service experiences and automating routine tasks. However, these opportunities must be accompanied by responsibility, ensuring ethical development, transparency, and a focus on human collaboration. Thank you all for your time and attention today. We hope you've gained a good understanding of our AI-powered chatbot project. Now we'd be happy to answer any questions you might have.